Okay, we're going to start on the homework here for 2.5. All right, so this section involves what's called the chain rule, which is a very important rule when it comes to taking derivatives. It allows us to take a derivative of very complex functions. Now, there's systematic ways to approach this, and then there's just kind of, after you've done enough of these, you can do them without writing out formulas and following procedures. So I'm going to try and do these functions as best I can using a little bit of both. So here's a way that I would have explained this problem in the notes. First of all, we have that our function, y is equal to, we want to see we have a composition here. We have a cube root of something, and then inside of that we have the 1 plus 5x. So the inner function would be the 1 plus 5x. The outer function would be the cube root. Now, what they're asking for here is for us to identify the inner and the outer. So the inner function would be that 1 plus 5x. So 1 plus 5x. And then the outer function, we refer to it as a function of u. So what we're going to do is we're going to look at this entire inside as being our u. And therefore, the outer function is cube root of u. Now, if we use the methodology that the book uses, they say down here, dy dx derivative of y with respect to x will be the derivative of y with respect to u times the derivative of u with respect to x. So what they do is they say, okay, well here's our function of u. We're going to take derivative of that with respect to u. And then we're going to take derivative of this with respect to x. Now, here's how I do it. What I do is I say, okay, look, our y is the cube root of something, which I'm going to call u. And then the u is some function inside, which is just 1 plus 5x. And then what I do is I create a table, and I take the derivative of each of these. So on the top one, I can take the derivative of y with respect to u because u is the variable. And remember, this right here was u to the 1/3. So derivative of that, the 1/3 comes out. I subtract 1 from 1/3. I get negative 2/3. And then I have down here, I can take the derivative of u because that's the left side, and with respect to x because that's the variable on the right side. And the derivative of this, well, derivative of 1 is 0, and derivative of 5x is just 5. So what I need to do now to get my answers, I need to multiply this times this. And so that's what they have right here. Now, what you do next is, well, I'll show you this. I'm going to rewrite this here. This is 1/3. U is actually 1 plus 5x. Remember that? That comes from here. And then to the negative 2/3. And then we still have times 5. So now what we do is we take this, we drop since we have a negative 2/3 exponent, we drop it to the bottom. And we also notice that there's a 3 on the bottom from the fraction, and there's a 5 on top. So I have the 5 on top. I have the 3 on the bottom. And then I'll have the 1 plus 5x to the 2/3. I've moved it down so the exponent's positive now. Now, raising something to the 2/3 is the same as squaring it and then taking the cube root, which is why what we get here is the squared. That's our whole thing there, 1 plus 5x, we're squaring it, but then we're taking the cube root of that. And so this is the answer matches up with what I did. Okay, let's take a look at this function here. Capital F of x is equal to that quantity to the 4th power. So again, what we want to realize is that we have an outer function. The outer function here is the last thing happening, which is that whole thing's being raised to the 4th power. The inner function is everything inside of it, and that's just a polynomial. I can take the derivative of that, no problem. So again, I'm going to follow the way that I've done it. I'm going to say that I'll call it f. Okay, that means this left side is f. F is equal to something, which I'll call u, raised to the 4th power. And then that thing that's being raised to the 4th power is x to the 4th plus 5x squared minus 5. And then I make my table. I take derivative of each of these. The derivative of f with respect to u is equal to 4u cubed. And then the derivative of u with respect to x is 4x cubed plus 10x. And of course, derivative of negative 5 is 0. And now what I do is I multiply these two together. So when I multiply those, I get, and this is going to be my derivative, okay, my final derivative, and it will be with, well, let me just write it this way. This will be equal to 4u cubed times, now I need this in parentheses because I have two terms, 4x cubed plus 10x. And now what I need to do is just make sure I replace my u here with whatever u is, and remember u is up here. So now I can say my derivative with respect to x is 4 times now u, which was x to the 4th plus 5x squared minus 5, all of that to the 4th power, or yeah, 3rd power. Okay, so I have finished this part, and then I just have to write everything else that's out there. 4x cubed plus 10x. And that's it. So you can see that that's what they have right here. And they do come over here, and I believe they factor 2 out of these, a 2x out of this. You factor a 2x out of that, pull it out to the front up here, you'll get your 8x, and then the rest of it, they kind of carry it on to the next line over here, as this. Okay, next one. All right, this one's a little tricky. Number 3. We have y is equal to, well, first of all, notice that we have a quotient, right? So we have a numerator, we have a denominator. So if I call the numerator f, and I call denominator g, we already know that the derivative of y will be f prime g minus g prime f all over g squared. So let me write down what f is. F is equal to r, and g is equal to, watch, I'm going to rewrite that. Square root of r squared plus 3 is actually r squared plus 3 to the 1/2. So there's my f and my g functions. I just need derivatives of these. Well, the derivative of f is just the derivative of r with respect to r, which is just 1. So we're treating r like x. And then on g, here's where we have to do a little work. G is actually its own problem now. This is a composition. This is an inner function, and then it's got an outer function, which is the 1/2. So I'm going to write it this way. G is equal to something to the 1/2, and then that something inside is r squared plus 3. And I make my table. So I'm doing a chain rule just on this part. So taking the derivative of g requires a chain rule. Now, the derivative of g, let me move over a little bit so I can squeeze this in here. The derivative of g with respect to u will be equal to the 1/2 comes out, subtract 1, so u to the negative 1/2. And then the derivative of u with respect to r will just be 2r. And then I multiply those two together, and I get basically my derivative of g, which is 1/2 u to the negative 1/2 times 2r. Notice the 2's cancel. So I'll bring that r out front. And notice that I have my u to the negative 1/2. I drop it to the bottom, and then I'll just put a square root instead. And now I need to replace u with what it was, and just remember that u was actually r squared plus 3. So I put down here square root r squared plus 3. Okay, so now I have everything. I look back over here. I needed f prime. I've got f prime. I needed g. I've got g. I needed g prime, got g prime. I needed f, I've got f. So I can just plug everything into the formula. So y prime will be equal to the derivative of f, which was 1, times g, which was r squared plus 3 to the 1/2, minus the derivative of g. Now, derivative of g was down here, r over square root r squared plus 3 times f, which was r. All of that over g squared. So if I take g and I square it, notice that there's g. If I square it, the square root goes away. I'll just be left with the r squared plus 3. Let me try and clean this up. I don't need this 1 out here. That's really just square root r squared plus 3 minus r squared over square root r squared plus 3. All of this over r squared plus 3. And to clean it up a little bit more, what I can do is I can get a common denominator in the numerator. So remember, this is over a 1. So I'll need to get that, I'll need to introduce, I'll squeeze it in here. I'll need to introduce on top and bottom square root r squared plus 3 over square root r squared plus 3. That way we both have the same denominators there and we can put them together. When I multiply this times this, I get r squared plus 3, the roots go away. Then I have minus, and then the r squared, which was the numerator up here, all over my common denominator, which is this. Then all of that over r squared plus 3. And now I have a complex fraction, so I'll write that denominator over 1. And then this is where I come in with that reciprocal, like this. These got flipped up. And when I multiply straight across there, and let me notice that those r squareds cancel. So I just have a 3 on top. Then on the bottom, I have square root r squared plus 3 times r squared plus 3. You could leave it like that, or you could notice that this is the same as 3 over r squared plus 3 to the 3/2. And that's because this right here is the same as r squared plus 3 to the 1/2. And then this right here is r squared plus 3 to the first power. Since these have the same base, we just add the exponents. 1/2 plus 1 is 3/2, and that would give you this down here. So I believe the computer would probably take either one of those. All right, let me take a look to check this. Where are we here? Yeah. Okay, there we go, right there. Okay, so let's make sure I've answered the entire question. Yeah, got it. Okay, let's take a look at this one. This one looks like it's going to be a little interesting. So we have composition because we have functions inside of functions inside of functions. So the last thing happening is I have a square root. So let me try and start to build this up. I think I'll go with a smaller pen here. I know that y ultimately is a square root of something. Now everything in there is this, right? So what can I say about u? Well, u is equal to 5x plus the square root of something again. So we're going to have two variables in here, but let's just do this. 5x plus the square root of 5x plus the square root of 5x. Like that. That's where we are, right? The problem is I can find up here, I can find the derivative of y with respect to u. That's no problem. I just, use the 1/2 power, bring it out. But over here, if I'm going to try and take derivative of u, we're going to need to take a look at what that is over here because we again have some chain rule. I can take derivative of 5x, no problem. but derivative of this is going to require some work. So I'll try and complete my table here. You're going to see we're going to run into a little bit of an issue. So derivative of this, remember this is u to the 1/2. So the derivative of y with respect to u is equal to 1/2 u to the negative 1/2. Okay, now if I try and take the derivative of u with respect to x, what I get is, well, derivative of 5x is 5, plus, now I need the derivative of this. Well, that's like its own problem because it's another composition. So I'm going to have to start like another separate piece of work down here. Okay, and I'm going to say right now g is equal to square root of 5x plus square root 5x. So all I've done is I've written this part as its own problem so I can find its derivative and stick it in over here. All right, so everyone